Testing, testing, 1, 2, 3.
Okay. So, Alex is about to give permission or forgiveness keynote. Alex needs almost no introduction. He's a senior engineering manager, right, at Google?
Senior staff.
Senior staff manager at Google and
Senior staff
engineer at Google, sorry. Recipient of the Frank Wilson Award, a big part of the EuroPython, the PyCon Italia organization, and definitely helped us scale to the size that we are today. Don't want to take more time out of this. Thank you.
Good morning, everybody. So the title of this talk obviously refers to the well-known motto, it's easier to ask forgiveness than permission, and we'll be dissecting that and its roots and its consequences throughout the talk. But first, I should point out that sometimes the best answers to forgiveness or permission is neither. And I start with a friendly note to the nice people who, every time I give a talk, tweet and comment about it, saying, oh, the guy's using Comic Sans. Well, my proportional font is not Comic Sans, it's Apple Chalkboard. It goes with a blackboard background, and I've written the brief phrase, this one, in both fonts. Can you tell the difference? Or do the left one, the elegant Apple design font, look to you like the right one, the goofy Microsoft design font? If it does, I'm really sorry for you, but take it up with Apple. I believe Apple has a certain sense of visual design, and I'm more willing to rely on them than on my omnipresent critics. So sometimes the best answer to permission or forgiveness is neither. You've done something unconventional, violating nobody's rights and your duty or anything. You get criticized, stand your ground. Don't ask anybody for permission about what font to use in your presentation. It's your decision. And don't apologize if some people don't like your fonts, because there will always be people who don't like your fonts. So pick something safe for visual design like Apple, and you have moral support to just stand your ground. Okay, that's a secondary one, but where does this issue, permission or forgiveness, comes from? It comes from the motto of Rear Admiral Grace Murray Hopper, PhD. It's easier to ask forgiveness than permission. What we know from the one line about her in the annals of the US Navy is that her PhD was in mathematics at Yale, and her lifetime was 1906, 1992. That's a bit too little. We need, and it's not hard, to dig a little bit more and find something about this woman who was, for obvious reason, nicknamed the Amazing Grace. That's from the song title, of course, and Grace was her name, but she was amazing. She worked on what can arguably be called the first actual computer as in a computer deployed in more than one instance, the Mark I. She invented compilers, the very concept of compiler, as we'll see. Some would count this as something she should be asking forgiveness for. She was the core person at the heart of the COBOL programming language, and she had a nice twist or introduced possibly the term debugging. Among her many accomplishments, in 1969, the Data Processing, I forget what the M stands for, Association, proclaimed its most prestigious award, Computer Science Men of the Year. And Mrs. Hopper won the first Computer Science Men of the Year. That tells you something about the actual role of women in our discipline versus the consideration they've been given throughout. We just, definitely 40 plus years ago, but still today, we have a hard time admitting that the man of the year can actually perfectly well be a woman. She was also the first American citizen in history and the first woman in history to be named a distinguished fellow of the British Computer Society. In her service, she won the highest peacetime award in the military, the Defense Distinguished Service Medal, and the president also awarded her the National Medal of Technology. The pictures here, which I unfortunately cannot highlight because my batteries died, the leftmost one is Grace Hopper showing off a nanosecond and a microsecond. What she's holding there is a roll of copper wire, which is about 30 centimeters, about a foot. So that's about what a nanosecond looks like when light travels it. Because of the speed of light, 300,000 kilometers per second, in a nanosecond, light, the fastest thing, can cover about a foot. And in a microsecond, 1,000 times as much, which is the length, the 300 meters length of the whole roll of wire. This visualization is what led her back in the 60s, when the most powerful computers were getting bigger and bigger, to predict eventually for a computer to be fast, it will have to be small for obvious physical reason. Because if a nanosecond matters, which in the 60s was like science fiction, if a nanosecond matters, every foot of wire you have in your computer loses you a nanosecond, and that's a very big loss. The second image is a page from her laboratory notebook, where she taped and identified the first computer bug ever actually found. I suspect the term bug, meaning error, was already used from the context, but in the Mark I, they found out that a certain bug was due to a moth having short-circuited a valve, so the moth got fried, and the third and fourth are the ship named after her and the USS Hopper and the stemma of that ship. So what did she mean when she said it's easier to ask forgiveness than permission? She was specifically talking about her life's work, producing an incredible amount of innovations while working within a large bureaucratic organization, mostly the US Navy. That's where she spent most of her working life, but she also worked for Honeywell and other private companies, but when they get big enough, they're bureaucratic too. The point is that whether you call them captain or some middle officer rank or middle manager, an organization, a large organization with bureaucracy to stick together, like it's literally a survival role for the organization, needs some very competent, hardworking people who sit at their desk, and their main job is to listen to the innovative, revolutionary, disruptive proposals of the creative part of the company, the technically strong people, sometimes young, ambitious people. Listen carefully, weigh the pros and cons, and say no. That's the point. They must be shown to listen carefully, so the person who's proposing this revolutionary idea will know their considerations are being taken into account. But in the end, they will always tend to say no. A middle manager's job is to say no, so that the organization can stick to its plans and schedules and deadlines and so on, and survive as an organization. Nevertheless, bypassing this structure apparently worked very well for Grace Murray Hopper. Her amazing track record of delivered innovation. I mean, think about it. If you had invented the concept of compilers, would you think you'd still need to prove yourself and produce some other revolutionary inventions. I would say I'd start sleeping on my laurels quite happily if I'd done that, not her. The fact that within the Navy she was promoted all the way to Commodore, the term Rear Admiral is exactly equivalent to Commodore and is due to some retagging of titles within the Navy, proves that her achievements were very well acknowledged within her own organization, and the recognition showered on her from outside, such as a Computer Science Man of the Year title and so on, proves that not only was she very visible and well rewarded within the Navy, but in the outside world too. Here's more examples. So let's start with a lower right-hand corner. That's what she was doing when she was 7 years old, according to her autobiographical notes. She was fascinated by alarm clocks, mechanical ones, giving the times, and every time she got her hand on one, she dismounted it to see exactly how it fit together, did a very good job of it. Putting it back together again didn't really work, which is where the forgiveness comes from. Her mother wasn't particularly happy to have to buy new mechanical alarm clocks all the time. But she obviously learned a lot about the things in question. The upper left is a magazine she founded. Her original title for it was Chips Ahoy, where the Ahoy was intended to be a reference to the Navy, although it was a United Armed Force magazine. And the chips, of course, were the newly emerging integrated circuits, which she was absolutely convinced would be the key to really fast computing in the future because of the speed issues. Unfortunately, Chips Ahoy is a popular brand, at least in the US. I'm not sure if it's around in Europe, of chocolate chip cookies, and Nabisco Brands, I believe, owns the trademark. So when the Navy found out that she was using somebody else's trademark without permission as a title of an official magazine of the armed forces, they removed the Ahoy very rapidly. Actually, Nabisco Brands later declared it would have been honored if asked. So that's one case where asking for permission might have worked better than just going ahead and doing it. But what I personally consider her core accomplishment out of the main accomplishment in her life is the concept of automatic programming. Back in the 40s, when programming still often meant rewiring machines, or if you were lucky using punched cards with machine code and so on, she was absolutely convinced that one could design a system whereby a program was entered in a language closer to human beings, closer to the problem, and another program would transform this human readable form into machine code. I know that sounds so corny, but 70 years ago, a bit less than that, 65 years ago, all of her managers at UNIVAC at the time said, that's absolutely stupid. It's obviously impossible. So what she did was to go ahead and do it and deliver the first, we don't use the term automatic programming these days, but the first compiler for this not particularly good language, I have to admit, called Flowmatic, but it was the first one. It was the one that set on fire people like Bacchus at IBM saying, hey, we could do that for formula translation, from which the Fortran language comes from. So scientists could actually program without bothering engineers, computer engineers all the time to transform their mathematical computations into something the machine can execute. So why does asking for forgiveness, that is, going ahead and doing it, and then if it doesn't work, apologize, versus asking for permission before actually starting to do it? The bureaucrat, or middle manager, or middle officer, or so on, inevitably, no matter how brilliant they may be as a person, work in a structure where their incentives is to deny permission whenever asked. Why? Because the more innovative, disruptive, risky projects they approve, the more they have to work to keep track. The more their life gets complicated, there may be a career risk. There's like 100,000 of funding for this project, doesn't work. 100,000 for that doesn't work. Eventually, the upper management says, where is this guy splurging all his budget? Is not into these crazy projects that never deliver anything. Remember, they widely quoted, I don't know if the statistic is correct, but they say that 4 out of 5 startups fail. I suspect that 4 out of 5 highly innovative, disruptive, revolutionary programs fail, or more. So giving permission and funding and things for somebody to go ahead and do something that's obviously impossible, like a compiler, may carry a career risk. Simply saying, nope, that's not in our plans, that's not in our schedule, just to stick ahead and follow the strategy, which next round we'll be doing cabling of the machine in this way, and so on and so forth. Mostly, those denials, those cases where the bureaucrat says no, and a great idea is never actually started, do not leave any trace on that manager's track record, so they won't present a career risk. Nobody's going to fire him because he blocked this impossible project from ever starting. There are exceptions, which is why we know those no's, where the things crossed organizational boundaries. For example, Western Union, which is still alive and well as a payment processor, used to essentially own telegraph throughout North America. And Graham Bell went to them to ask for cooperation in this new revolutionary concept of the telephone. And we have the letter of the middle manager from Western Union saying, nah, that will never work. Who would ever want to actually speak to somebody, listen to something that way? Telegraph is much more obvious, practical, cheaper, and so on. This telephone idiocy has no future. That was a letter that was preserved in the archives, so we know. But probably by the time it was pretty obvious that the telephone was destroying Western Union's business, that manager was probably already retired and enjoying his retirement. So from his point of view, denying the permission worked. So what if you go below the radar and go ahead and do it? Well, in most cases, when all is said and done, the incentives of the bureaucrat or middle manager will be to grant forgiveness for much the same reason. Well, first of all, the issue may never even come up. It's such a roaring success that obviously everybody's celebrating and nobody's noticing the little detail that the guy didn't actually bother to ask his boss for permission and funding. One example that's very well documented in the book called the Autodesk Files. Autodesk was born with a very clear plan to automate essentially what we would now call office operation, word processing, spreadsheets, and so on. The key technical person among the founders just wasn't too convinced that would actually work for them, while he saw an enormous space completely outside of the business plan, nothing to do with what the firm had been set up to do automatic drafting with a computer. He didn't bother to ask for permission. He just went ahead and developed AutoCAD. Now, nobody, I suspect, after the fact, when AutoCAD proved to be the moneymaker for Autodesk and the dominant computer-aided design program in the world, when I said, you hadn't had the proper form signed and you didn't have the funding and you took engineers' cycles away from the important thing, word processing, and which never actually worked for them. So, first of all, you may be lucky, your innovative project works, nobody's really going to ask for either any kind of forgiveness or anything. But if it doesn't work, I'm not saying as in some explosion destroying the lab or something like that. We're talking mostly about software projects, so doesn't work probably means wasted so much time and computational resources at worst. Still, making a big deal out of it for the middle manager might be counterproductive. The path of least resistance, least work, least complication, least career risk is to give you a dressing down and don't do it again. Because if he makes any bigger case out of it, the question will come up from the top manager. So why didn't you notice what the guy was doing in the lab all day instead of following our carefully crafted business plan? And that might be unpleasant. So does it only apply if you're working in a bureaucracy? No, it doesn't. I strongly believe there are several other examples of how asking forgiveness, which means trying, making sure to deal with the case in which it doesn't work, is far superior to checking every possible condition to try to ensure against failure. I'll give some examples in Python, of course, otherwise I wouldn't have been invited to speak here. In concurrency, source code control systems, and networking, and business even. We'll get to it. It's particularly relevant because it's very much applicable to open source as well as to actual commercial enterprises. And then we'll focus on important cases where this approach doesn't work. Sometimes the rules, the principles, the organizations are sensible and should be adhered to, and then there's the moral side of things, which we'll conclude with. Let's start with the bad example of asking for permission. This code first desperately tries to make sure it can open a certain file path in order to read it, and otherwise does something else. I tagged this approach as LBYL, which stands for look before you leap, which is thought to be traditionally in other areas wise. It could be read that way, you're right. In this case, the guy's trying to look first and leap after. Well, this code is so un-Pythonic, is nowadays explicitly brought up as a bad example at docspython.org, which, by the way, is an awesome site, and I strongly recommend to everybody. It's not just a reference manual. It also shows you good examples and bad examples. What's wrong with it? Anybody care to volunteer? Please.
The file can be gone between line 2 and 3.
That's a great example. The file could be gone between line 2 and 3. You don't have, in the vast majority of cases, full control of that file system and other processes and things that might be operating on it. So whether you have it or not when you ask for access, you may not have it when it's time to open. Or the permissions could have been changed, which is actually much faster, and so on. So having checked 1 microsecond ago doesn't necessarily guarantee. Sure, probability is in your favor, but if you're dealing with probabilities, that's pretty flaky programming. And the appropriate approach is the forgiveness one, that is, you try to open it, and if it doesn't if it doesn't let you open the file, then go with the error case. In this case, I'm returning a default. There's a difference, as some pedant, in the good sense of the word, pointed out. It's the use of a real ID versus effective ID. in Unix like system. On the other hand, the difference only exists if you're using a set user ID on your scripts, in which case you have a much bigger problem than this little distinction, and I strongly recommend you don't. Anyway. One thing that used to be considered a similar case was checking for types. Using isInstance, for example, to say if it's a number, I want one more, otherwise I want some default value, was considered equally inappropriate for because it's trying to check everything, and duck typing was considered much preferable. This is, as you know, the term duck typing, which I think incorrectly credited as having introduced. To me, the idea of duck typing always sees a duck in a typewriter there. But so the problems here are very different than the other forgiveness cases. Basically, okay, there's not only integers and float. What if I have a decimal or some kind of fraction or other kinds of number? I can't list them all, and so this is why the checks may be too restrictive. On the other hand, in modern Python, we have a few abstract-based classes which exists specifically to enable the isInstance check. Anybody who's writing a type they want to behave like a number can register with base class numbers.number, which essentially doesn't add any functionality, just enables this idiom. So if there is an applicable type class, I'm sorry, type class is not a Python term, it's a Haskell term, but I think abstract-based classes are a more general concept. A class whose only role is to say which types match a certain abstract concept, to me is very close to the Haskell type class, so I like to use this term. There aren't all that many. It's well worth memorizing. They're in collections and numbers. If you may be using a framework which adds a few more, if your use case exactly matches, like, is this a number? Well, checking for that specific type class is perfectly fine, and is what you should be doing. So this leads us to, so I need to check, but it's something else that's not covered in the existing ABCs. Should I write a new one just for type classes purposes, not enabling common factoring of things, not all the many other things that an abstract-based class can do for you, just enable isInstance? I would say the point is not how is it going to influence your code so much, but it's a conceptual and architectural one. If there's some important, well-recognized abstraction, like a polygon, an image, a sound, depends on what your application field is, there's potentially very divergent implementations that are warranted depending on, for example, speed versus memory trade-offs and so on. And you're essentially developing a framework that hinges on that as a core concept, then I think is the only time you should think of adding new abstract-based classes. Of course, it's best if you can supply useful auxiliary methods, something that should probably apply to all implementations of that concept, except if the implementation overrides it for speed purposes. If you're subclassing an existing abstract-based class, that tends to be a good symptom because the existing ABC was already a general concept and you're just having a slightly more specialized or strongly more specialized one. But just don't do it as an implementation trick. It really needs to be in your design, in your architecture, architecturally valid, conceptually valid. Just don't become the man with a hammer to which all problems are nails. Oh, by the way, even better from my point of view than permission and forgiveness, when applicable, are defaults. Not only will I never use, or try to never use, check with if has after, then do something, but also they try x.foo, blah, 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 most of the time get after with a default value for the attribute in case the attribute is missing, and similarly get on a dictionary with a default value turn out to be much smoother. This isn't so much a conceptual problem, this is very much an implementation problem. More often than not, your code flows more readable and smoothly if you simply have a plan B in place, and that plan B can be expressed by furnishing a default. Moving on from Python, consider the concept of optimistic concurrency. A traditional permission-based approach to concurrency is you need to protect all shared resources by acquiring appropriate locks or mutual exclusion constructs of any kind. Once you finally own all the resources you need for the operation, then you perform the set of operations and release the resources, release the locks, and so on. Very often, it's faster and usually smoother to program, if you can get around to it, to perform, just try and perform the desired set of operations within a transaction. The only truly crucial issue is that the system must be able to detect and give an error if the transaction has suffered collision with another transaction. So some of the resources had been altered from other threads, processes, nodes, whatever, while you were processing that. And then, hopefully rarely, you can retry that. Software transactional memory is a great example of optimistic concurrency, and I hope we'll really hear something more about it from Armin Riegel, who's standing right back there, and a year ago taunted us with promises of STM in PyPy. But databases, the good ones, have been doing that for a while. That was possibly the core innovation of Oracle when it was a fledgling database, while other databases made by huge companies like IBM DB2, very good databases, but went around locking everything in a half. Oracle had optimistic concurrency in place from day one, except in cases of heavy overload on a transaction that gained an enormous amount of speed compared with DB2. So they got a foot in the door, and look where they are now. But my favorite example of optimistic concurrency, because I think we all get it, is not so much based on technical things, but on human behavior, although it does involve technical aspects, because I'm talking about source code control. Traditional systems of source code control meant, okay, I need to change foo.c. So I somehow, from the central system, acquire it as mine for now. And then I can modify it and check it back in. What's one of the many problems there? So you get foo.c, start modifying it, say, oh wait, I need a tweak in foo.h. Meanwhile, on the other side of the world, one of your colleagues has gotten foo.h, started to modify it, say, oh wait, I also need a tweak in foo.c. The only known example of human deadlock. You're holding foo.c and waiting for foo.h. He's holding foo.h and waiting for foo.c. Whoops. Now, if you're sitting in the same room, that deadlock can be broken more easily, but with distributed development, it's obviously unfeasible. By the way, I call it old because it was the first way it was performed, but it's still available in commercial products. I'm told Visual Source Safe works that way. ClearCase works that way. A lot of products need you to check out the files you're modifying, and so you're blocking out everybody else until you're done. What's the alternative? Be a bit optimistic. Just do your changes and test and more changes and so on. Now you have something ready to release, probably code reviewed and so on, and you release it. Whoops, somebody else did some changes to those files while I was changing them. Well, in this case, there's a human being in the middle, so presumably some smarts, some brains, work on it, reconcile the differences, and then you can submit again. That's not all. I mean, we've all fought with conflicts. We had a change set that we had been toying with for a long time, and the conflicts grew beyond boundaries. But don't focus on that one case. 90% of the time, 99% of the time, you're much happier working with the forgiveness-based approach to source code control than you would be with the permission-based, where you acquire all the rights and exclusive rights for the duration. A completely different example. In the early days of local area networks, Ethernet was already out and about, and IBM came up with a better system, the token ring. Well, the token ring is a permission-based system, so you can be sure there will never be two nodes talking, putting bits on the wire at the same time and damaging each other, because only the one node that holds the ring is allowed to put bits on the wire. If the ring goes around, the token goes around in a ring, and most nodes have nothing to say, so they just pass the token on. All the time passing the token on is pure overhead. In the non-infrequent cases where only one or maybe two nodes have anything to say at this moment, a lot of idle time is wasted just passing the token around. Meanwhile, in the Ethernet network, and if the wire is quiet and I have something to say on the node, I just start talking. Well, what if somebody else starts talking at the same time? The only issue is you need to be able, with certainty, to detect the collision. Both nodes that started talking at the same time are informed, whoops, there was a collision, and they both back off by different, hopefully different, random times. And that proved to be so much more efficient than collision detection. Now, essentially, totally dominates the layer 1, I think, yeah. Again, there are limits. If you're under unbearable overload, token ring is bad, Ethernet can totally go to disaster. But it's not always optimal to design for the worst case. The worst case, where every node needs to be talking, Ethernet would be a total disaster. But in the real world, it just doesn't happen much. And finally, one not necessarily technical example. How do you go about launching a new product on the market? Well, if you're a traditional big firm, you go slow and safe. It's a permission-ish. It's like, let's make sure everything will go fine. We make studies, we get focus groups, we found out what the consumers want, do top-down design and development based on our determinations. Eventually, at some point, we'll have a perfect product ready, and then we'll launch and find out that a small company who just hit the market running and launched and iterated as they found out in the real world what consumer wanted, has eaten our lunch and taken our market share. That's an agile approach. In a sense, it's forgiveness-based, so I launch a beta, put out a beta, it kind of works, not quite, but something, and then I iterate rapidly. Another way this has been put is fail, but fail fast. And of course, if feasible, iterate and fix your failures. Of course, this varies by product type. I would not recommend, if your business model is to develop aircraft carrier ships, that might not be best, or surgical devices for implantation into people's hearts. Mm-hmm. Those you might want, but we're mostly software people, mostly this, I think, is very applicable to us. So when is it not applicable? One, when there are sensible and appropriate rules and principles in place and an organization, a process to deal with them. One very simple example I would strongly recommend to every software project with more than one person, mandating a code review before something is committed to the reference repository or trunk or whatever you guys want to call it. That's in a distributed system, this need not exist, but it often does. And saying that something doesn't get into the repo unless it's code reviewed is, I think, a very good principle. And I've heard many arguments for and against, say, well, we don't need that because we do pair programming. I think you still need that for major changes because two people pair programming, the better pair programmers they are, the more likely they are to get in sync, to start thinking of things in the same time. And so it becomes obvious to them that you do this, and they don't bother commenting on why is it doing this and this, and so on. Another pair of eyes that wasn't like involved actively in the development will spot it and say, this is unclear, this is suboptimal, whatever. Even with pair programming, I still strongly recommend the mandatory code review from somebody outside of the pair. I realize that this concept of working with the system may be too mainstream and therefore unpopular among some young hotheads, but if the environment is designed right, this will often work in your favor. One strong example, there are places, all the sensible ones, that mandate preliminary reviews by experts of architecture, product plans, and eventually code, specifically spotting privacy and security issues. Privacy and security architecture cannot really be retrofitted to a system that was designed sloppily or actually designed great from the point of view of most measures, but without considering security risks or privacy risks. That part of the problem is that the issues of security and privacy are somewhat orthogonal or even opposite to a lot of the things you want from a piece of software. So you could be a great software developer and have a totally blind eye to certain security risks. And you can't really, more often than not, you can't really retrofit effectively the security aspects. You really need to re-architect and rework the system. You want a somewhat structured process of review, which includes both a preliminary review of the architecture before coding starts and review after. This can easily become too rigid, so you need to find the sweet spot, not too hot, not too cold, the Goldilocks spots in process, in formality, which will depend a lot, okay, what kind of data are you holding? Somebody's top score in a game, you can afford to be slightly relaxed. Maybe it can be hacked. Nobody will be seriously damaged. Banking data with like the ability to send money to a different account, you'd better have a pretty rigid approach. So it does definitely depend. Finally, another case in which bypassing procedure and just barging ahead ready to ask for forgiveness is not a good idea, is a lot, possibly most, common human interactions. So far we've mostly been talking about technical and possibly business aspects, but consider one of the deepest sentences that has ever been written. In any course of action, consider acting in such a way that humanity in yourself and humanity in other people is always at the same time as an end, never just as a means to your end. I will not quote all the rest of the Grundregeln, but I seriously recommend pondering this. Let me give just one example which I hope isn't controversial. One case in which just barging ahead without asking anybody would, I believe, strike us all as wrong. Okay, you want to get your doctorate, but your thesis just ain't working out. Hey, wait a second. There's this obscure thesis published somewhere nobody else will think of checking, which I could just copy and pass as my own. You know, there have been cases of people who've been kicked out of posts like CEO of big corporations because it turned out that 20 years ago they had done exactly this. The problem is not getting caught. It's that it's simply wrong. In this case, the person whose thesis you're copying has rights. Copying is fine, but you need the permission or implicit permission, and you need to make clear that you're quoting and what is your original contribution, because in a thesis you're supposed to give some. Just one example out of many. Never use the concept of it's easier to ask for forgiveness than permission to justify to yourself obviously immoral behavior. I hope nobody ever thought of that, but I would just like to make sure about that. This is again the URL at which you can download the PDF of this presentation. I don't know if we have, how much time we have for Q&A?
15 minutes.
That sounds good. There should be. By the way, I should make clear, I don't only welcome questions, of which I may or may not have an answer, because you may have noticed that the title of this presentation was a question, and there hasn't been really an answer, just a lot of considerations about it. Anecdotes, life experiences, electronic music. Welcome. See? It's working.
Is it this thing? Ah, okay. So back when you were talking about the old duct typing way and the new way, so are you saying that we shouldn't be just doing duct typing anymore?
We should be doing duct typing a lot of the time. For example, I don't think we have any abstract class, although I haven't looked at 3.3, for a file-like object, but would take a lot to convince me to use an abstract-based class for that, rather than just try and call the read method or something.
What's the biggest thing where you dared to hope for forgiveness? Instead, what's the biggest thing in your personal, quite big experience where you trusted to get forgiveness instead of asking for permission?
So it was at a startup, and we had this really inappropriate process for software development. Overreacting to an early cowboy attitude, we'd put up and written down all sort of procedures, and on a Friday night I completely bypassed the concept because there was a bug that was affecting one of our early customers, and of course I should have had a code review, but there was nobody else around, and the customers was working on Fridays and Saturdays, and they needed our system to work, so I just banged ahead and bypassed the blocks that I put in place myself, and then went to be pretty late and showed up on Monday, sheepish. Have I broken anything? Apparently I haven't, but that was giving the bad example. I didn't want us to return to the cowboy ways. And we slowly developed or learned to do agile processes as opposed to no process at all, or strict waterfall that doesn't let you fix bugs.
I just thought of something. If you simplify the last thing about you should ask for permission if you're doing something that's sort of morally wrong, then it sounds like if you simplify that, then it feels like bureaucracy is always morally wrong. You can always.
No, they're not. It's like it cannot be wrong to breathe. for being, because it's indispensable for survival. For the survival of a large organization, I suggest you read Weber. What he has to say on bureaucracy more than 100 years later is still worth reading. Bureaucracy is a condition of survival of the organization, so it can't be wrong.
Is that a question?
Just coming back to source code, I was seeing a presentation about Mercurial, where they have implemented this
I'm
locking.
sorry, I can't hear you. Try to.
I saw a presentation about Mercurial the other year, and they've implemented that locking, and the reason that was given is that merging can become impossible. If you, for example, edit an image, Word document, these other forms of sources, merging is difficult, and I've been through a couple of merges myself with C files, Python files, and I think it's not that easy to say it's as simple as that. That was one question. I have another one. I'm into Ada as well, and Ada Lovelace is on my mind as the woman who invented the first programming language. Is that sounded like somebody else did it? Also a woman, which I would like to congratulate you on, to pronounce that.
Okay, so taking the second question first about Ada Lovelace, I had the good luck on Friday to be at Google London, where there was a talk about the two men who almost invented computers, Turing and Babbage, and why they couldn't quite make the last step. Ada Lovelace didn't invent a programming language, and she wasn't the first programmer. First programmer was Babbage, the builder of the analytical engine. What Lovelace contributed was the concept that computers are not just about numbers. Babbage was totally fanatical about mathematics, computing functions. That's what all he ever wanted to do. And Lovelace pointed out that given the pervasiveness of mathematics, this actually enabled applications, what we would call applications. Music was an example she brought. Music can be dealt with as if it was a mathematical function, even though for us it's pleasure, it's art. About merges, if you do change sets that are too big and complicated, merging can become a nightmare. Although, think about it. That means if you had to do it by locking, you would be locking every file around, and nobody else in the team could be working at all. That would not be a great alternative. To me, the preferred alternative is to slice up your change sets as small as you can. I remember one recent case where I just had to rename one field in an API because it was very badly named in the first place. What I actually did to enable to do it gradually, I first duplicated that field in the API with both the old and new names, with the new name working fine and the old name giving a warning. I checked that in, and then turning to the client side of the API, changed the places that access the old name to access the new name, and only then went back. It's a bit more work, but it allows there to be 10 small change sets instead of one huge all-encompassing one. And whatever source code control system you're using, a change set that touches 100 files is going to kill you, one way or the other. Yeah.
Actually, on Ada Lovelace was probably the first debugger because she corrected an error in one of Babbage's programs. I was at the same talk he was. So.
Oh, yeah, I had another interesting example of forgiveness for permission. Python actually came out of that. Python was pretty much a skunkworks project during its first few years. And I just sort of decided that I wanted a new language and did it. And management had nothing to say about that.
Good move.
I have a question on a related topic maybe, which is trust versus control, and it's related to what you said about proposing design reviews for security issues. And I've been pushing for this myself, and the problem that I find is that sometimes reviewing the design and making sure that there's no security issue that hasn't been addressed is so often as much work as writing the design in the first place. So then, of course, maybe you want to trust your coworker and say, okay, I trust that you did your design thoroughly, and I can just trust that if there's any issue, you pointed it out. But that causes me to miss some of these issues. But then if I impose too much control, it's like I don't trust anybody. I just need to do all your work again myself to really make sure that you did well. And I don't feel comfortable there either. What do you think?
I think if no real security expert ever trust anybody. Otherwise, they wouldn't be a security expert. Being a security expert doesn't mean being a genius in cryptography, although that helps and so on. It really means some sort of paranoid mentality. I'm sorry. That's why it doesn't necessarily overlap with being a great programmer. Some great programmers just don't have enough mistrust to be that good at security. They just don't think like the evil guys. It's hard to think like the evil guy and therefore prevent the evilness from happening. I wish it wasn't that way, but by the way, I should remember to quote one of my greatest mentors in the early days of Google, Bogdan Kokozel, when I put that argument to him and said, no, he's a founder of the reliability engineers at Google. He says, yeah, I know, security people claim they're paranoid because they think all human beings are trying to break. That's not paranoid. That's wildly optimistic. It's not just human beings. The whole universe is trying to break your system. Human beings are a problem, but earthquakes and asteroids coming down, it's like, that's a reliability guy. That's even more the next level beyond the security.
Very last question.
Okay, I'm sure you were joking about the paranoid stuff, but I'm no security expert, so I don't mind. But I'd like to ask you if for some, in particular for some kinds of activities in our trade, there are traits of behavior that are helpful to being a programmer, but might be related to some kind of obsessive compulsion disorder.
I personally think the most relevant quote I can give is from Donald Knuth. A programmer, I think he used the term developer, but same thing, is someone who sees the microcosm and the macrocosm at the same time. His eyes are seeing the tiniest detail and the biggest picture at the same time. That's if you want to be a Donald Knuth level programmer, but I suspect not a few of those are sitting or standing in this room right now. And you know what? In most human interactions, unless you learn to shut up, it's like you're discussing with a friend a big picture of something, and you notice a detail is wrong and completely shift the level of discourse. That doesn't make you popular. So that's one example. To do architecture, to do programming really well, to deal with abstraction, you need to see the most minute detail and the most grand sweep at the same time, which makes you pretty unsuitable for social interaction unless you learn to shut it up.
Okay, thank you. The next keynote is Fabio Cincotti. It's going to be about brain-computer interaction and how we are starting to develop software that can help people with ALS to actually move and be helpful to themselves without another human being next to them.